So welcome to your 21st century lecture experience. So today's question, we're going to kind of pick up where we left off last time. So let me remind you what we did last time. So we said, can you determine the number being represented here? And I have 1, 2, 4, and this is in base 8. So the idea behind this is that we have different positions, and so that's the 1's position. But this is no longer the 10's position. This is going to be the 8's position. And this is no longer the 10 squared. This is actually the 8 squared position. So what we have, this is going to be equal to 1/8 squared, so 1 times 8 squared, plus we have 2 8s, so 2 times 8, and then plus 4 1s, so 4 times 1. And you can take out your calculator, and we can crunch this number over here. So we have 1 times 8 raised to the 2 plus 2 times 8, and then plus, if you want just 4, you can multiply it by 1 if you like, and we get our answer of 84. So 1, 2, 4 base 8 represents 84 things. So last time I gave it to you in a certain base, and you wrote it in basically base 10. The next type of problem is encoding. So I give it to you in base 10, and you have to write it in a different numeral system. So here we have 137, and we want to write this in the given numeral system. So how do we write this base 5? And the idea behind this is to use these cups. So let me give you a hint. So here's the hint. We imagine we have these cups. So we have a 1's cup, a 5's cup, a 5 squared cup, a 5 cubed cup, and a 5 to the 4th cup. And we put things into the cup, and that's going to represent 137. So the first thing you realize is that we don't need this cup because it's too big. But we can use this cup, the 5 cubed cup, and I'm going to put one thing in it. And when you put one thing in this cup, that's actually 1 5 cubed, or 125 things. And then you ask yourself the question, how many things do you have left over? So you can take 137 and take off 125, because by putting one marker in that cup, you've represented 125 things. And so you have 12 things left. So how many markers are you going to put in the 5 squared cup? And hopefully you say 0, because this number 12 over here is too small, and 25 is bigger than 12. And then the 5's cup, how many things are you going to put in there? And you'll say 2, because that's going to get us to 10. And we had 12 things. By putting 2 markers in this cup, we represented 10 things. So we have 2 things left, so we'll put 2 there. And so this is equal to 1, 0, 2, 2. Now this is not base 5. This is not base 10. It's base 5. So I'll write a 5 down here, so everybody knows that's base 5. So you have 2 1s, 2 5s, no 25s, and 1 5 cubed, which is 125. And if you add those up, you get 137 things. And so that's how we write 137 in base 5. Now how do we write 137 in base 2? So now let's pretend, we don't have the cups, but we can make cups. It's not too hard. And so in base 2, you're going to have a 1's cup. So here's my 1's cup. You're going to have a 2's cup. You're going to have a 2 squared, which is equal to 4. You're going to have a 2 cubed, which is equal to 8. You'll have a 2 to the 4th cup, which is equal to 16. You'll have 2 to the 5th, which is equal to, 32. And you just keep on going until you get past 137. And so 2 to the 6th, which is 64. And then finally, you'll have a 2 to the 7th cup, which is 128. And if you go any higher, 2 to the 8th is going to be too big. And so these are my cups, and so you can draw them. So that's my 2's cup, my 2 squared cup, my 2 cubed cup. And you can do this a lot faster than I can do it on here. And 2 to the 4th cup. But you get the idea. 2 to the 5th, 2 to the 6th, and then 2 to the 7th. So you can draw your own cups and then play the same game we were playing before, where you figure out how many markers do you put in each cup. So obviously you're going to put one thing in here, and that represents 128 things. And so now I have 137 minus 128 things left. So I have 9 things left. So it's going to go 0, 0, 0. And with 9 things left, I'll put one marker here. So that's 8 things, 0, 0, and a 1 here, because that'll give me the 9. So 8 plus 1 is 9. And so that's going to be equal to, if I write this base 2, it's going to be 1, 0, 0, 0, 1, 0, 0, and with a 1. And then I'll write a little 2 down here so everybody knows this is base 2. So this is really 1, 1, 1, 8, and 1, 128, and that should give me 137 things. So on your homework, you want to use this idea of cups when writing a number in our numeral system, in the base 10 numeral system, and the various numeral systems given. So either base 5 or base 2 or any other base 6 or base 7 or base 8, any base. All right, so the next thing, or the last thing we're going to kind of talk about here is how do we add and multiply in different base numeral systems. I like this these sort of problems because I think they're interesting from the point of view that it kind of demonstrates how little we really understand how to multiply and add. So basically what we've done is we've memorized a bunch of addition tables and multiplication tables. And you'll see in your handout you have these tables. So you have a base 10 table in your handout, so that's given to you right here. And we were taught these basically in 1st and 2nd grade. I think we were probably taught our base 10 addition tables, and then starting in 3rd grade, we start learning these multiplication tables. And the handout, there's also the base 5 addition and multiplication, and the base 2 addition and multiplication. And if you know these tables, then you can do addition and multiplication in these various bases. Now, you don't have to memorize these. These will always be given to you. And we're going to start with these two examples. And so we'll start here with 22 plus 6. And what we're going to do is we're going to add this like we would normally do in base 10. And so, I say 6 plus 2 is 8. You could use this table here and say 6 plus 2 is this 8 right here. But I know that 6 plus 2 is 8. And then I bring down the 2 and I get, obviously, 28 things. Now, when I do this base 5, I do exactly the same thing I did above, except instead of using the base 10 addition table, I'm going to use the base 5 addition table. Now, since I don't have this table internalized, I don't count base 5 usually, I'm going to have to use it. So this will always be given to you. And so what you want to do is just like you did above, you just take the 1 plus 2, and if you look over here, 1, and let's do it like this. If you look at 1 plus 2, you get back 3, and so that's 3 things. And then if you do 1 plus 4, what are you going to get? Well, you take 1 plus 4, and you're going to get back, and I'm going to abuse the language, you get 10 things. And so you write a 1 and a 0. And we'll write the word base 5 down here, because this is really, if you think about it, this is 3 1s, 0 5s, and 1 5 squared. So it's really 25 plus 3, which what it should be is 28 things. So that's how you add base 5. Now we're going to do the same thing in base 2, and I already gave you the numbers in base 2. So 22 looks like this, whereas 6 looks like that in base 2. And we'll add in base 2. We only need the base 2 addition table to do this, but you add 0 and 0, and just like in base 10, you get back 0. If you add 1 and 1, well, you can look at the table here. If you take 1 plus 1, you get back 10. So right here, I'll write a 0, and they taught me to carry the 1. And then I'll take 1 plus 1, and again, just like last time, 1 plus 1 was 10, but when you add another 1 to 10, you get to 11. And as long as you don't get into 2 or above, you're going to be okay. So this is actually, if you want, 1 plus 1 is 10, plus 1 is 11, so I can write 1 and carry the 1. And then 1 plus 0 is 1, and then I get 1 here. And so that's base 2. All right, so remember this, this idea that when we counted base 2, we said we start with 0, and then we go to 1. And then instead of writing 2, we write 1 and 0. So this is really 1, 2, and 0 1s. And this is 1, 2, and 1, 1. And then as soon as we have to get to 2 here, what we can do is we write basically 1, 0, 0. All right, so you have 1, 1, 1, 2, and 1, 1, so that's 3. And here I have 1, 4, 0 1s, 0 2s, and 0 ones, which is 4. And you can keep on going in this manner. All right, let's look at another example of adding base 5 and base 2. And so here we have 19 plus 9. And so I know I can use this base 10 addition table when I add. And again, I have this basically internalized. I know 9 plus 9 is 18, but I could look here. 9 plus 9 is 18. And I write an 8 here, and I carry a 1. And 1 plus 1 is 2. So I get this 28. Down here, I've written these numbers base 5. So 3, 4, base 5 is actually 19 things. If you think about it, this is 3 5s and 4 1s, which is 19 things. And this is 1 5 and 4 1s, which is 9 things. And now when I add these base 5, I should get 28 things. And what I'm going to do is I'm going to use this, again, this base 5 addition table to do it. And so when you take 4 plus 4, what do you get? Well, 4 plus 4 is, I'm going to abuse the language and say 13 things. And so I'll write a 3 right here and carry the 1. And then I'm going to take 1 plus 3. So 1 plus 3 is 4 things. And if you add 1, well, what happens when you add 1 to 4? You get to 10 things. And so then I'm going to write a 10 right here. And this is base 5. And you can check your answer by saying, okay, this is 3 1s, 0 5s, and 1 5 squared. So that's really 25 plus 0 plus 3, which is, yes, 28 things. Let's do it base 2. So I've already written 19 and 9 in base 2. So in base 2, this should be 19. And in base 2, this should be 9. And I'm going to add 1 plus 1. And this is real simple. 1 plus 1 is 10. So I copy down a 0. And I carry the 1. And again, 1 plus 1 is 10. Plus 0 is still 10. So I write down a 0. And I carry the 1. 1 plus 0 is 1. Plus 0 is still 1. 0 plus 1 is 1, and then you just get a 1, base 2. And I can check my work. I have 0 1s, 0 2s, 1 2 squared, which is 4, 1 2 cubed, which is 8, and 1 to the 4th, which is 16. So 16 plus 8 is 24, and then if you add another 4, you should get 28. So think about it, and you'll see you get the right answer, 28 things. All right, so that's how you do addition, and what you want to notice here is that it's exactly the same algorithm as base 10. You just use a different addition table. Now multiplication is exactly the same too, and so let's take a look at one example here. So when you take 8 times 3, we're actually going to wind up using both tables, so base 10 and a base 10 multiplication table. But I really don't need these because I already know them. But again, you can see how you're actually using these. 8 times 3, look over here, and you were taught 8 times 3 is 24, but you can use a table and look it up. And then you were taught to write a 4 here, and then a 2 up here. And then you were taught to take 8 times 2, and again, I know that's 16, but really it's because I have this table, 8 times 2, internalized, which is 16. And so 8 times 2 is 16, and you add 2 to it, and I know that's supposed to be 18. So I write 1/8. So I get 184 things. So now let's take a look at this at base 5, and we're going to follow the same algorithm, but use a different multiplication table. Now we'll use this base 5 multiplication table. And so I want to take 3 times 3. Now in base 10, that's 9, but it's going to be different in base 5. So 3 times 3 in base 5 is actually 14. And I'm abusing the language, but what the rule is, I'd write down the 4. And then I'd carry the 1. And then I'm going to do 3 times 4. So over here, I'll take 3 times 4, and that's going to give me 22. And when you add 1 to 22, you get 23. And as long as you don't hit the 5 or go past it, you're good. So 22, if you add 1 to 22, you get 23. And now I'm going to write a 0 here, like they taught me, and then I do 1 times 3. And so 1 times 3 is still 3, so I'll write a 3 here. And 1 times 4, well, 1 times 4 is still 4, so I'll write a 4 here. And now that I'm done with my multiplication, I'll move on to addition. And so on my addition, So make sure now you move to the addition table because we're doing addition now. And I see 4 plus 0. Well, 4 plus 0 is still 4. So I just copy down the number 4. And then 3 plus 3, now I have to be careful on this one. My brain wants to say 6, but I know I can't use the numeral 6 because I'm in base 5. So 3 plus 3 is actually 11, which is really 6, right? When you write 11 base 5, that's 1, 5, and 1, 1. So we use this 11 to represent 6. So I write a 1 here, and I carry the 1. And then I'm going to finish up here. I'm going to take 2 plus 4. So 2 plus 4 is 11. And again, I'm abusing the language. And then I'm going to add 1 to 11, and that gets me down here to 12. So then I'm going to write 12. And then I'll write this little base 5 down here. Now, if this was an exam and I completed the exam, I'd want to come back and check this. And so what this says is basically I have 4 1s. So I have 4 1s. And I have 1 5. So I have 1 5. And I have 2 25s, which is, what, 50? And then over here I have 1 5 cubed, which is 125. And if I did this right, I add these up, and I get 175, 180, 184. And so you can check your answer up here, and yes, it matches. And so I'd be happy with this answer because they match. And so this is what I would do to check my work on an exam after I finished everything. Now base 2, we're going to use first this multiplication table on the right when we multiply. So remember, when we multiply, we first use the multiplication table. And we want to take 1 times 0. And what's nice about multiplying by 0, so 1 times 0, you still get back 0. And so the multiplication actually is really easy. So I'm going to get 0, and 0 times 1 is 0, and 0 times 1 is 0, and 0 times 0 is 0, and 0 times 1 is 0. Now, remember, binary code or binary numerals are used in computers, and so you want to see how this is basically, basically on or off, and how you could use the idea of being on and off to add and multiply here. And then you write an extra 0, and then you have multiply everything by 0. So 0 times 1 is 0, 0 times another 1 is 0, 0 times 0 is 0, and then finally, let's fix this. My marker got out of control here. So 0, and then finally 0 times 1 is 0. And we just continue on, so now I write 2 zeros, and then 0 times 1 is 0, 0 times 1 is 0, 0 times 1 is 0, 0 times 0 is 0, and then 0 times 1 is 0. And then finally, after I write 3 zeros right here, I can finally then actually write down something other than 0. So 1 times 1 is 1. You can look over here. 1 times 1 is 1. And 1 times 1 is 1. And 1 times 1 is, again, 1. And then 1 times 0 is 0. And then here I'm running out of space, but I have another 1 right there. And then I add all the columns, and I'm going to get 0, 0, 0, 1, 1, 1, and then a 0 and a 1. And let me move this over because I'm kind of running off of the edge right here. Let's see if I can't grab all this stuff and move it over. There we go. All right, so you can see I add up these columns, and I am using, just so you know, I am using now the base 2 addition table, and the reason for this is I'm done multiplying. Now I'm just adding up the columns. So I get 0, 0, 0, a 1 when I add all those up, a 1 when I add all those up, a 0 when I add all those up, and then a 1 when I add all those, and then this is base 2. And that's my answer. And you can check this by saying that's the 1's position, the 2's, the 2 squareds, and so on, and you should get 184 thing. So I think this process is really interesting, these algorithms which we feel so comfortable with, but when we look at different bases, we realize that we really don't understand at all what we're doing when we're going through the algorithm. Now, when you break these things down and say, like, you're taking 23 times 8, so you're really adding 23 8 times, or you could say, you're taking 3 8 times and 28 times, and that's giving me 184. Then we understand multiplication, how it really is. But this algorithm that we've learned, that we've internalized, really demonstrates to us that we don't understand at all what multiplication it really is, which is actually good, because this means we can program things like computers and calculators to do these operations. A calculator or a computer really does not know what multiplication is. It just basically takes in some software and you put in the numbers, and then it runs the software and gives you the answer.